Hi everyone. So in this session, we are going to see the introduction part about the electrochemistry. So this electrochemistry topic is one of the important topic for term 2 examination. Okay, for term 2, 12th chemistry. Okay, so this topic we are studying under the term 2, 12th chemistry, 12th chemistry for academic year 2021 to 22. Okay, now. So under this topic, we need to study the three important topics we need to study. One is we need to study about the galvanic cell or electrochemical cells. One topic is electrochemical cells we need to study. Cells is one topic. Second topic is electrolytic cells. Electrolytic cells. And third topic is conductance. Conductance. Conductance of electrolyte. Conductance of electrolytes. Okay. So this is the three topics that we need to cover in this part. Okay. Now we'll see one by one these topics. So before going to this topic, first we need to study some introduction part about the electrochemistry and some important terms we need to learn. So after learning that important terms, first we'll complete the next slide. We'll complete the electrochemical cell. Next, in the third slide, we'll complete some basic things about the electrolyte cell. And next, we'll go with the fourth slide. We'll complete the conductance of a electrolyte. Okay. Now, so now we're going to see some introduction part about the electrochemistry. Okay. Now, actually, so electro means electricity. Chemistry means chemical energy, chemical reactions. Okay. Now, so electro means electrical energy. We can simply write as electrical energy. Electrical energy. Okay, this electro means electrical energy. So chemistry means a chemical reaction. Okay. So this chemistry, electrochemistry will give a relation between the electrical energy and simply it will give a relation between the electrical energy and chemical energy. Chemistry means chemical reaction. So in the chemistry, there is chemical energy only will be there. Okay. That means electrochemistry. The word electrochemistry consists in chemistry, that is electro means electrical energy. So chemistry means chemical energy. Chemical energy. So this chapter will give a relation between the electrical energy to the chemical energy, and also will give a relation between the chemical energy to the. So that means under this chapter we are going to learn how this electrochemistry will give a relation between the electrical energy to the chemical energy and chemical energy to the electrical energy. Okay. So now, so just we'll see the once definition here. Okay. So electrochemistry is a branch of physical chemistry. The branch of physical chemistry, so which deals with the study of production of electricity from a spontaneous chemical reaction. Spontaneous chemical reaction is one step. That means, so in the first step, so under this chapter we are going to learn how that means under this study we'll study how the production of electricity will releases. So how this production of electricity will take place from the spontaneous chemical reaction is the one step. The second up, and how this electrical energy used to bring out a non-spontaneous chemical reaction. That means, so under this chapter, just we are learning how this chemical energy is converted into electrical energy. At the same time, how this electrical energy will bring out the chemical reaction. Okay, simple. So under this chapter, we are going to learn how chemical energy, so bring out the electrical energy. At the same time, how electrical energy, by using electrical energy, how we can able to perform a chemical, how we can able to produce the chemical reaction. Okay, so So in this chapter, just it will give a relation between the electrical energy to the chemical energy and chemical energy to the electrical energy. Okay, now, so by using this electrochemistry, okay, very, very important topic. So by this, we can able to produce so many metals like a, so with help of this electrochemistry topic, so we can learn how we can able to produce this sodium metal, so magnesium metal, calcium metal, aluminum metal. Okay, so these are the means we by using the chemical electrical energy, we are bringing the chemical reaction. I mean, some new chemicals will comes out. Okay, so because of that, not only we are getting the new chemicals here. Okay, sodium, magnesium, calcium, aluminum. Okay, at the same time, this electrochemistry also very, very important in the electroplating process. Okay, and also in the purification of the metals also, this it will play a very important role. Next, in this batteries, cells. Okay, so we use various instruments. Okay, so this will work under the electrochemistry. Okay, this battery cells will work under the, so this in this batteries and cells, the chemical energy is converted to the electrical energy. Okay, so in the electroplating and all, so electrical energy is converted to the chemical energy. So this top three are electrical energy bringing chemical reaction. Electrical energy brings chemical reaction. Chemical reaction. Third one is chemical energy brings out chemical energy. Chemical energy brings out electrical energy. Electrical energy. That electrical energy we use for a working of for various instruments. Okay. So this is about some introduction part. So along that, we should know some important terms also. So one is conductors. What do you call as conductors? So conductors are the substances which allows passage of current through them. Okay, conductors are the substances, chemical substances, which allows electric current to pass through them. So that we can call as a conductors. Suppose if they're not allowed, we can call as a insulators. Okay, suppose if you allow now, we can call as a conductors. If the substance do not allow electric current to pass through them, we can call as a insulator. Not allow now, not allow means we can call as a insulators. Okay, we can call as insulators. Okay, next, actually we have two types of conductors. We have one is metallic conductors, or we can call as electronic conductors. So other name of this metallic conductors, electronic conductors. Okay, so these are the solid substances. Okay, so metallic conductors are the solid substances which allow electric current to pass through them by the movement of electrons. Okay, so with the help of the movement of electrons, so these metallic conductors, they will allow the passage of electric current to them. That means, so in the metallic conductors, electrons will carry the electric current from one end to the other end. So best example is all metals. Okay, now, so next we have a liquid conductors. Liquid conductors. So the liquid conductors we can call as the electrolytic conductors or electrolytic substances. Okay, so these are liquid conductors, which also will allow the passage of electricity through them. Okay, in the fused state or in the aqueous state, the semi-liquid state, semi-solid state, or in the pure liquid state. Okay, so while electricity passing through them, some chemical composition will occur. Because of the chemical composition, some ions will come out. That ions will help the liquid to, or help the electricity to pass through them. That means, so in these electrolytic conductors, ions will act as carriers. Ions will act as current carriers. Will act as a current carriers. Okay, this will act as a current carriers. Who ions? That means both cations and anions, both will act as a current carriers in the electrolytic conductor and in the electrolytic substances. Okay, these are purely fused state and the aqueous state, not the solid state. Okay, now So once again, if you see the types of, so we'll see in details about uh, the conductance of the electrolyte. We'll see separate topic is there will study completely. But just now I am giving just introduction part about this electrolytes. Okay, electrolytic conductors are electrolytic substance. Okay, now here also will come across with the types of electrolytes. Okay, now just I am giving the introduction part here. Okay. Now, electrolytes are two types. One is strong electrolytes, which are called as strong electrolyte. Now, the electrolytes which completely ionizes in aqueous solution. Okay, the electrolyte which ionizes completely in aqueous solution, that we can call as a strong electrolytes. Best example is sodium chloride. Sorry, hydrochloric acid, sodium hydroxide, and potassium sulfate. This will act as a strong electrolytes. Suppose when you prepare aqueous solution of this hydrochloric acid or sodium hydroxide, so they will be completely ionized. They completely ionized to ionizers like ions, cations, and anions, and they will act as a current carriers. So strong electrolytes are the very good conductors, very good conductor of electricity. Now, weak electrolytes. Okay, so these weak electrolytes, so they will dissociate, only partial dissociation will happens, only partial dissociation in aqueous solution. Okay, so best example is acetic acid, okay, carbonic acid. Okay, same way we can give us ammonium hydroxide, and hydrogen sulfide. So these are the best example of ammonium hydroxide. And so these are liquid part, all are liquid only, and carbonic acid. So these are will act as a very weak electrolytes, very weak electrolytes. Why they are called as a weak electrolyte? Na? So they dissociate very partially, very partially in the aqueous solution. In aqueous solution, they won't ionize completely in aqueous solution. But if you go to the strong electrolyte, they ionize completely. Okay, so we'll study in details in the next slide about the while studying the conductance of electrolytes. We'll study completely about their conductance, how the conductance of a strong electrolyte and a weak electrolyte. Okay, so just we are learning about some introduction part about the total things. Okay, next. So as I said, under electrochemistry, we are studying the relation between how the electrical energy will convert to the chemical energy, how chemical energy will convert the electrical energy. Okay, now the cells which convert chemical energy into electrical energy, the device we can call as a electrochemical cell. The device which convert chemical energy into electrical energy, the device we can call as the electrochemical cell. Okay, next, the device which convert electrical energy into chemical energy, that device we can call as a electrolytic cell. Okay, now we'll see the few differences between these two. So next, we'll go with the electrochemical cells, how these electrochemical cells work. We'll see one by one. Next, we'll see some differences between the electrochemical cell and electrolytic cell. We'll see some differences between these two. But because very important, they will ask us some few basic questions. Okay, now first we'll see the electrochemical cell. So already we learned this electrochemical cell is the device which convert. First difference is, so this is the electrochemical cell is the device which convert chemical energy into electrical energy. Okay, next. So this electrolytic cell is a device which convert electrical energy electrical energy into chemical energy. Chemical energy. Okay. So this electrolytic cell is a device which convert electrical energy into chemical energy. So this device will convert chemical energy into electrical energy. The first difference of these two. Next, the second difference. So actually, this electrochemical cell is the combination of two half cells. This either it is a combination of two half cells, okay. The two half cells may contains same or different electrodes, sorry, it contains same or different electrodes in same or different electrolytes, in same or different electrodes. So different electrolytes. Okay. So actually, this electrochemical cell is the combination of two half cells. The two half cells may contain same or different electrodes, and that electrodes may present in the same that electrodes in same or different electrolytes. Okay. Next, you will see the about if you see the electrolytic cell with a single cell. It is a single cell. It is a single cell containing same electrode present in same electrodes present in same electrolyte present in same electrolyte. Okay, is a single cell. Okay, what is a combination of two half cells? Electrochemical cell is the combination of two half cells. Electrochemical cell is the combination of two half cells, but electrolytic cell is the combination of just is the single cell. Okay, next, third difference. You see the third difference. So in the electrochemical cell, anode is a negative. Anode is a negative. Why? Because electron will releases from that anode. Okay. Why? Because oxidation reaction takes place here. Okay. Here oxidation takes place. Because of that, electrons will come out. Because of that is the negative part. So cathode is positive here. Okay. In the electrochemical cell, anode is a negative, cathode is a positive. Okay. You will see here in this electrolytic cell. So anode is positive. Anode is positive, and cathode is negative. Cathode is negative under the electrolytic cell. Okay. Next, if you see the fourth difference. So movement of electrons takes place from movement of electrons. If you see the movement of electrons, so that will takes from here anode to cathode. Anode to cathode. Okay. So in the here the movement of electrons will takes place from the anode to cathode. In the external circuit also. In the external circuit. Anode to cathode. In external circuit. Okay. Now here, so in this case, the electrons will enter into cathode, leaves out anode. Here the electrons enters into cathode and leaves through leaves by anode. So the moment of electrons. So here the moment in the electrochemical cell, the moment is from a anode to the cathode. There is external circuit from external circuit. Okay. So you can see here. Okay. Okay. Is the anode part with the cathode part. Okay. So already said the combination of two half cells. Okay. So here we have a salt bridge will be there. Okay. Now, so suppose we connected these two electrodes by the conductor. Okay. So here the anode, the electron will take place. Electrons, movement of electron is external of the all in the external circuit. Okay. It will move from a anode to the cathode. Okay. But here, so here totally the single cell here, totally single cell. Okay, totally single cell. Okay. So here the electron enters to the cathode, leaves by anode. Okay, that one. Next. So here, next fifth difference is here the cell reaction is spontaneous. Here cell reaction is spontaneous. Cell reaction is spontaneous here. But here is cell reaction is non-spontaneous. Okay. Here cell reaction is spontaneous. So here in the electrolytic cell, in the electrochemical cell reaction is spontaneous. In the electrolytic cell, non-spontaneous. Okay. Last one. Here is salt bridge is required. So here salt bridge required. Salt bridge required here. Salt bridge required here. Here no requirement of salt bridge. Here no required. No required of salt bridge. No required of salt bridge. Okay. So these are some of the introduction part about the electrochemistry. Okay. So here we covered what is the definition of the electrochemistry and important terms under the electrochemistry. Okay. So along that we should know two important terms. Next. So here, okay. So at anode, always oxidation will take place. Oxidation reaction will take place. Next at reduction. So reduction will take place at the cathode. Okay. So at anode, always oxidation will take place, and the loss of electron will take place, and the reduction will take place at the cathode. So there is a gain of electron will take place. Gain of electrons. Okay. So this is about introduction part. In the next slide, we'll go completely about the electrochemical cell, that is galvanic cells. Okay. Thank you. Have a nice day.